Welcome and thank you very much for joining us for this fourth webinar in the series by BCS and PRSB on health informatics standards. I'm Mike Anderson. I'm the technical lead for standards on BCS Health and Care. I'm joined by Charlie McKay and Miriam Namar from the BCS. Today's talk, as you all know, is going to be about FHIR. It's going to be by Rick Smithies, who will introduce himself in a moment. He'll talk for about 40 minutes, and then we'll go through some questions and comments in the chat. So if you want to put any comments or questions into the chat as things go along, please do. We're recording this webinar, and the recording will be made available in due course, though it may take a few days because there's a bit of a backlog. However, the slides should appear early next week. And I think without further ado, I'll hand over to Rick at this point for what promises to be a very interesting talk on a topic that is of considerable importance and great interest to many people. So over to you, Rick, and thanks very much for agreeing to do the talk.
Mike, right, thanks so much indeed, and thanks to all of you for having me. Welcome, everybody. Yeah, as Mike says, I'm going to talk to you about FHIR, HL7, and a few other things. Let's get going. Okay, just a slide of my details. I'm an independent consultant, but I'm technical chair of HL7 UK. More about what that is momentarily. I work on the FHIR project. Lots of people do. It's a kind of volunteer project, open source project with thousands of people involved. My email address there if you want to get in touch. And some acknowledgements. These slides, like a lot of the FHIR community, comes from a wide range of people. Graham Grieve, kind of the godfather of FHIR. He's presented for HL7 UK in London before now, so a few of you may be aware of him, and some other names from the community. All right, so first of all, a slide about HL7 UK. I'm from HL7 UK, as is Mike, in fact. We're the UK part of HL7, health level 7. There's a little aside down the bottom here about why it's number 7. Many of you will know that. But we're a standards body, and we're the people who make FHIR. FHIR is the name of the standard. HL7 is the name of the organisation. And HL7 UK, yeah, we're the UK affiliate, as it's called, and that's our web address there. You can Google us pretty easily or follow these links. Yeah, we're an organisation that consists of our members, basically. We get things done, and but done by our members. We're volunteers mostly. We're not a not-for-profit organisation. So yeah, join, support us. We promote interoperability, and we try and do things the right way to save everybody money. Get data in front of patients and clinicians and so on. All right, so let's get right on with it. FHIR, a bit about the background of FHIR, what it is, what you can do with it. It's a technical presentation, I guess. So I won't go too much into medical concepts and the systems out there that use FHIR, but I'll talk about FHIR itself and give you a good idea of hopefully where it sits. So a bit of kind of prehistory, really. Let's say where FHIR came from and the requirements for FHIR came from. I mean, this is the healthcare group, isn't it? So you guys know, we'll all know that people are always trying to move healthcare information from one system to another. And we've been doing it since the kind of 80s with increasing levels of success, but there's plenty of work to do. And the landscape has changed a little bit, of course, over the time with things like the internet and, internet time and agile software and more devices, smaller devices, mobile phones and connected gadgets, bigger devices, if you like the cloud and web and off-premises, on-premises things. So, the landscape has changed, and we need a healthcare data exchange standard that's fit for modern purposes. And until FHIR came along, there really wasn't such a thing. But what do we have now, or what did we have before FHIR? If you've heard of HL7 at all, you probably might think of HL7 as the standard that hospitals, primarily hospitals, rather than GPs or anybody else, tend to use. HL7 is the name of the organisation, but it's also what HL7 version 2 tends to be called. People say, yes, we support HL7. So HL7 runs around inside the hospital, usually from the lab to the PAS, or the Master Patient Index, and from the PAS to the radiology department, and maybe prescribing department and so on. And when a patient is admitted or moves beds or whatever, the different systems in the hospitals will be synchronized with HL7 messaging. It's a kind of 35-year-old standard. It does its job. It's fine. We're not trying to replace it. FHIR is not coming along to rip and replace by any means. But it has its limitations. It's as I say, it's a very old standard. It's borderline glorified CSV. It's purely text-based with some arcane syntax. There's no kind of modern infrastructural support for it really. It needs a sort of a migration path. So maybe about 15 years ago or something, we had HL7 version 3, which was a kind of modern, I don't know if it's a reboot of version 2, a newer, more complicated, more flexible, early internet XML based era standard. And a powerful standard, successful in certainly in England and a few countries. The English National Programme uses it, and there's millions of V3 messages every day, all the electronic prescribing. Every time somebody looks up a patient on the spine, it all works on V3. So, it's good, it does some stuff, but it proved to be pretty complicated. We lost some of the simplicity of version 2, some of the directness of version 2. So successful when pursued by large organizations like a national level body. So the NHS did a big program, and whatever you think about the national program of a few years ago, a lot of messaging did get deployed, and it's still running today. But the trouble is nobody likes it. None of the technical people who use it really like it. It's a hard standard to understand, update, learn, etc. So, and for that reason, it didn't take off across the world, particularly the US didn't really get into it, and it seems a lot of software in health comes from the US. That's a bit of a problem. CDA, perhaps not so prevalent in the UK, but this is the document standard, exchanging clinical documents, kind of like the PDF of healthcare. That grew out of V3, so that CDA has been pretty successful, especially this time in the US. So where it kind of, it was what V3 could have been in a way. But it's a document-centric standard. As I say, it's like PDFs, only based in XML. So that was successful, but it's not everything is a document. We need something that's more like API calls for getting data from one system directly into another. Machine level communication, transactional, more like the old HL7 version 2, but updated. So documents don't do everything, and yeah, again, it's a bit in the legacy of the V3 XML sort of 2000s era standard. So a bit of HL7 history there. Here's a sort of landscape of difficulty of using up the side. It says log, but yeah, not particularly precise, but you get the idea, versus how expressive these things are. So you got things like XML, which is, it doesn't really say a lot. You can mark things up, but every XML document is different from every other XML document. Unless you take that and standardize it somehow. JSON would be in here at the same level. HTTP and HTML, yeah, it's just glorified text, really, isn't it? So very easy to use, but it can't tell you much semantically. Then we move into things like HL7 version 3 up here and OpenEHR. That have a lot of semantic depth. You can express things, you can take that standard and infer stuff just from the message that you receive without almost looking at the definition behind the scenes. So very powerful, but also up here on the difficulty scale. Things like SNOMED are starting to be powerful, but difficult to use. It has to be said that SNOMED is difficult to use. So we want to be down here. We want a standard that's like, super easy to use, but still has all the expressivity and power and meaning. So that's our target, and that there was definitely a gap, and that's where FHIR has aimed for, and you can be the judge of how successful that is. So a bit of thinking and soul searching and head scratching back at HL7. We had a successful 30-year-old standard and a not so successful 10, 15-year-old standard. What do we do? What would we do if we started from scratch today with a healthcare standard? these days it's all about REST APIs. I guess many of you listening will know what REST is, and there'll be some demos, and I won't define it too much, but we'll show you some REST soon. It's web-based access to data. So you take a data API and you sort of map it onto web technology. So that's all I'll say about that for now. But that's what your Facebook API will be like, your Twitter API, all the modern APIs, JSON, possibly XML, REST-based, web-based, HTTP-based APIs. So FHIR was born out of that idea of a web-based data exchange system. And here we have it. So it stands for Fast Healthcare Interoperability Resources. Obviously, that's a mouthful, but you get the idea. It's meant to be fast, as in easy to use. So fast to get going with, fast to deploy, fast to develop, and so on. Rather than, it doesn't transmit the bytes faster than any other standard. But having said that, it is quite compact and succinct compared to some other standards that have gone before. And it's about interoperability. It's about exchanging data from one system of healthcare to another. Free and open. So there's been a shift in the last 10 years or so, maybe. Things like music and general IP has become more open, and it's a good thing, unless you want to make money from selling albums. But yeah, in this modern sort of GitHub open source era, FHIR is free in both senses of the word. We've tried to be like the HL7 version 2 directness, because that's what tends to work. I won't say quick and dirty, but yeah, kind of quick at least. And we use modern web standards, so RESTful basis, web server based database servers using JSON, also XML, but increasingly JSON. And these are things that, even if you're not particularly technical, your technical guys will understand those things. People coming out of college, they know these things. They know the web stacks that deal with these things. Designed to be easy. And here's our. Well, I'll take you to that website and demo that a little bit later. But it's a nice, easy, and it's a nice Googleable. FHIR doesn't clash with too much other things. Pronounced FHIR, of course, but spelt like that, so you can Google it pretty easily, which is nice. And even simpler. So what is FHIR? Well, JSON set of health data resources. So I'll explain that in a moment. Plus this REST API. I keep mentioning this. It's your web-based access. So your data is mapped onto these web technologies. So our resources, and resources is a particular word that comes from this sort of RESTful API view of the world. It means your sort of endpoints, your pages of data. But in FHIR, there are data models. There are chunks of data. So, our patient model, our encounter model, our practitioner model, and so on. So these are our little data models. So we have JSON-based data models for describing things, and then a RESTful API for moving those things backwards and forwards. So that's really what FHIR is in a nutshell. So who's using it? Well, there's been various slides I've done of this over the years, and it gets more and more sort of bigger numbers, and FHIR is sort of selling itself these days. A recent statistic, quite good, from just back in June, Graham, the father of FHIR, 86 countries that he knows are involved with working with FHIR. So that's a good proportion of the world. And some non-traditional players, these not really healthcare verticals, but Microsoft have got an open source FHIR server. So have IBM, so Google. You can spin up a Google Health platform in the cloud and start throwing FHIR data at it in, as long as it takes you to get to their website and do it. Same with Microsoft. You can deploy it just at the drop of a hat. And I haven't listed all the kind of the verticals, the McKessons and the Epics and the Cerners of the world, but pretty much all of them have FHIR APIs. And if they don't, then they certainly need to be doing soon. This link here is a sort of our FHIR chat board, where you can go and ask questions about FHIR and try not to be too overwhelmed, because yes, there's 20,000 people registered on that, and that's not bots, that's kind of real people to the greatest extent. So it's extremely, it's live. So what's FHIR trying to do? we've talked about a couple of these things like using modern web technology. That's important. There wasn't really a standard in this modern space. It is open source. We said that already. And we focused it on implementers, coders, developers, whatever you want to call them, the guys, and including women, of course, guys and everybody who will be actually building this stuff, writing the code that gets the JSON, sends the JSON out of the web server. So that's not to say we've forgotten the clinicians and the the managers and all the rest of it. And there is some theory behind FHIR that's there, but we try and keep it practical, programmer focused, because we realize that all the academic standards and the clinically wonderful standards you can build are no good if when you give it to a developer, he goes, what the heck is that? So he or she needs to be able to get something, get the stuff off GitHub, find an example, start coding and get something done in a couple of days. Otherwise, it's not practical. Part of the kind of rationale and even the reason that is possible is to focus FHIR pretty strictly on this thing, this fairly arbitrary 80%. So we have this 80-20 rule, and we say if something is, for a given data item or collection of data items, a resource, if people who use that data will use, if 80% of them will use this data item, this patient name or patient address, then it goes into the FHIR standard. If it's something that most people won't use, but some people will, like the time that you were born or whether you're on a clinical trial. Now, these things are important, but perhaps your average GP system would not record the moment you were born. It would perhaps just have your date of birth. So there's some slight edge cases that don't go into FHIR directly to keep it manageable, but we have an extensibility mechanism for adding those bits on afterwards. Keep the core simple and maintainable, usable, readable, but don't forget the other stuff. So yeah, recapping on that. So we do have a rationale and a modeling behind the scenes, but we try and keep these resources simple, understandable. Test servers are around. There's free stuff, free code. I'll come to that a little bit later as well with some links for you, and lots of examples, because people don't read the specification. Nobody wants to read a specification. Let's face it. You want to see some JSON or see some XML, copy it, and get going that way. People start from the bottom and work up normally. So yeah, this 80%, we try and include things that we know that people need, and we don't include extremely specialist things that are only used in one geographic area. So if the UK has some specific thing that only we use, then you wouldn't put it in because the French and Germans and Canadian guys are not interested. The Finnish postal code that's unique to Finland, that's an extra, additional to the zip code or whatever, that doesn't go in because it's very important in Finland, but it's not so important in, Wales. So we do have this kind of scoping down. It's a deliberate, perhaps slightly strange, deliberate attempt to not cover everything. But it's a kind of a don't boil the ocean sort of thing. So FHIR deliberately plans to miss things out, which is kind of strange, but the alternative is to deliberately try and include everything. And we kind of tried that with HL7 version 3, and it became a bit overwhelming. So here's an example of what that 80% sort of might look like when we sort of make a cut and try and be a bit ruthless. This here, it's a big detailed slide. I'm not expecting you to read it all, but just to sort of see how kind of big it is. This is an address from the earlier HL7 version 3 standard. So the properties of an address. Now you can see, well, some things that look familiar. Address line, okay, that makes sense. You can see things like country and zip, a bit American, but yeah, you get the idea. State, that makes sense. But you see a lot of things that make no sense probably to you. Delivery installation type, I have no idea what that is. Delivery mode, don't know. Direction, maybe. Intersection, there's a whole bunch of stuff on here that basically most people do not need. I'm sure somebody needs census tract, but I'm sure that most people in Birmingham building a healthcare system probably do not need that. So there's a lot of fluff there. It's hard to understand looking at that. Where the heck where's my address? What is all this stuff? So we decide to cut that down. The red bits we don't need. The black bits we're going to stay. We'll get rid of those. The FHIR data type for address, is like this. So we have, what's that, 5 different lines of address, the basic address lines, your 1, 2, 3, maybe, country, city, state, stroke, county, postal code, and then 4 types of address: home, work, temporary, and old. So we don't have vacation address. We don't have, address in the mountains. We don't have sort of, we don't have various things. We just keep it simple. And then high or low dates for when that address applied. So immediately simpler. We know there's gaps in there, but that's where our extensions come in. They're outside of the core of FHIR. So that kind of illustrates this philosophy of FHIR. Try and keep it simple. Don't put everything in there. Appreciate there's going to be some gaps and kind of take it on the chin. Okay, so our web tech, these things all should be familiar to, if not yourselves, then your technical colleagues. The web, the web protocol, so we're exchanging data using web mechanisms. Data types, these are our booleans, our strings, our integers, and so on, based on the W3C set, for want of a better set of common data types, because data types are not that well standardized, but we make do. Particularly JSON, also XML, a little bit old school now, but still very much used. Even things like RDF, semantic web. There's a FHIR expression for RDF, not super widely used, but showing you that you can put FHIR on different, it runs on different technologies. You can run it on, if binary JSON comes along tomorrow or some new formatting language, FHIR is kind of independent of its output format. And we use this RESTful web-based way of reading and writing data. And then FHIR doesn't, FHIR needs to be secured, but it doesn't invent security. We don't try and, reinvent OAuth 2 or OpenID Connect or whatever it is that people in the world use for securing their things. We're web-based in the main, so the web technologies that are emerging, still settling, one bank will use a different thing from another bank, but we're sort of slowly getting there. Those technologies layer on top of FHIR. So FHIR is a little bit security agnostic, but FHIR does come with some recipes, some toolkits, white papers and so on, and layers to put that on. We tell you how to use those things, but they're not built into FHIR because that security is slightly on the edge of FHIR. Just to recap, this is free of charge, and free as in intellectual property. You can redistribute it. You can do whatever you like with FHIR. You can copy it. As long as you don't say FHIR is mine, or you can't do FHIR to somebody else, then you can basically do what you like with FHIR, which is a good thing. So we talked a lot about FHIR and kind of what it is and where it came from, but there's a slide here about what you can do with it. What is FHIR for? The I stands for interoperability, and we know it's healthcare because that's where we're kind of at. But if you've got an array of systems and they want to share data between one and the other, you can use FHIR APIs and FHIR data models for exchanging data between those systems. So it could be patient name and address, demographics. It could be appointments. It could be, your problem list, your medication list, a new prescription, booking for a clinic, a referral letter, you name it. Healthcare data could be your genomics history. FHIR has stuff for that, and it's for adding on to existing systems primarily. If you've got a system, a bit of a closed system, and you want to open it up, which is a good thing, to some other system which is built on a different technology, probably owned by somebody else in a different building on a different platform, Linux versus Microsoft, completely alien technology to each other. FHIR is the sort of glue that you can use for connecting those things together. So yeah, a blueprint for a data exchange mechanism for healthcare. So FHIR doesn't tell you about the internals of your system. You've probably got a system. It's probably got a SQL backend. It could be anything. It might be mumps. It might be cache. It might be a bunch of CSV files. It could be, a no SQL thing. FHIR doesn't mind about that. Your internals are your internals, but FHIR gives you this lingua franca in terms of a data model and in terms of an exchange pattern that you can use to sort of build on. And typically that works with a facade. So, we're not asking you to rip your internals out and replace them with things that are labeled FHIR, but we encourage people to sort of, walk and talk like FHIR. If it quacks like FHIR, sounds like FHIR, smells like FHIR, in effect, it is FHIR at the boundary of your system. And as this says, there's open source toolkits that let you bolt FHIR onto your system without having to rip and replace your system. But of course, if you are building a new system, FHIR makes a good data model, intended for exchange, but it's a well-analyzed, had hundreds of, man hours or whatever the term is of input into it by people from all sorts of organizations, decades of experience. So it makes a pretty good data model if you're starting to model healthcare data, maybe building that into your system. Or you can simply spin up a FHIR server. They exist. You can spin them up and start coding against them, pouring data into them, obviously with appropriate security and so on if you need to. So focusing back on our resources for a moment. These are our, if you remember, these are our chunks, our data models, our little, and they're designed in UML, little data models of data points for use for various things. Content model of FHIR, the unit of exchange. So we exchange resources in FHIR, normally by our web-based APIs, but we can also package them up into documents and quotes messages. So messages are more like point-to-point, perhaps a TCP/IP based exchange, rather than a more modern, RESTful post, put, get web-based thing. And these models are, informed by our history. Version 2 has its segments. Version 3 has its, RMIMs and so on. And we were aware of archetypes and all these kind of models in 13606. But we've come up with something that's, I guess, not really new in format, but just has a good level of content and is it's simple and fit for today's exchanges. If we go to FHIR, and I'll perhaps go there in a moment, you'll see a bunch of resources with names that are perhaps a little bit too hard to see. I'll zoom in a moment, but you can see a few familiar things if you look carefully, like patients, goals, medication, observation, and there's a few more than when this slide was grabbed a few years ago. We're looking at about 100 and 150, something like that. That's the order of resources in FHIR. So not 5, not 10, not 10,000, not 250,000 like SNOMED, but something in between. If you're building a clinical system, you would probably use maybe a dozen resource types, something like that. And there's some that you would be unlikely to use in any given system because your GP system might not use appointments and your appointment system might not use medication and so on. But all the bases are pretty much covered, and we're still adding new things to it. If there are gaps, we'll let us know and we'll try and fill them. So zooming in a bit there, here are some examples categorized. These gray things are not the names of the resources, just some grouping. There's a patient resource, so that's where your patient demographics goes. Encounter, if a patient is in contact with some clinical care or clinician, you put that in encounter, and then you link that to your patient. So these are different models, different structures linked together to make the picture of healthcare. So we see some familiar concepts. I won't sort of read them all out, but you kind of get the idea. But also note some more infrastructural things. So message header. Patients don't have messages, clearly. Well, maybe they do these days in this SMS message era. But a message header is a FHIR resource that describes like a FHIR interchange pattern. And capability statement is a list of abilities that are given FHIR server supports. Does it support searching? Does it support XML? Does it support JSON? And so on. So FHIR uses resources for its own kind of, laundry list. It keeps its own definitions in FHIR, in resources, in fact. So it's kind of resources all the way down, to sort of misquote. So what does this stuff look like? Here's some JSON. It's a patient resource, fits on a screen. It could be longer, of course. But we've got some familiar looking labels. The name of the resource is patient, an identifier, something that looks a bit like, SSN. I think that's an American example, probably social security number. And we've got name, family name, given name, familiar kind of things, birth date. Yeah, not too cryptic. kind of what you might imagine designing on the back of an envelope one day if you're going to do some demographics, lines of address and so on. That's JSON. We support XML as well, but increasingly people are sort of, it's more of a sort of JSON first world these days. There's a model behind that. It looks like this. We try and go for this Goldilocks sort of size. It fits on a screen. That's what you need to describe the core of a patient. What's that, about 30 odd fields in 4 boxes? Not too big, not too small. There's clearly things you could put in there that are not in there. Am I on a clinical trial? Not in there. Am I an organ donor? Not in there. But these things can be extended. But some familiar things, as we've seen before, gender, name, telecom, etc. So that's, so we're looking at sort of 100 or so resources of that size, some bigger, a few smaller, but we try to keep it kind of manageable and readable. So one resource doesn't get you too far. You need a collection of resources to tell the picture, as you might be sort of imagining. So something like this. Here's the patient resource we've just seen with a context-specific link. An arrow, but it's a subject arrow, an arrow, but it's a performer arrow. So, connections, but with a bit of context. Connecting a procedure resource to the patient who it's for, with the practitioner who did the procedure, with the encounter, recording the date and time of the inpatient stay or the trip to the GP where they had their something done to them, and why we're doing it. In what context. Is it because of their diabetes or because of their earache or whatever it might be? And then maybe there's a diagnostic report from the procedure saying that we studied the sample and it turned out that the blood sample was fine or whatever. So a series of collaborating resources, classes, whatever you want to call them, make up our sort of picture of healthcare. So it's a RESTful web-based standard. So we put our data onto web servers. Yeah. So instead of having databases, we have web-enabled databases, if you like, or at least it looks like we do. We expose the data through a web engine. The real data might be somewhere else in the background in some, Oracle or SQL Server database, but we serve it up through web addresses, secure typically. And then we have our FHIR keywords. So this is a FHIR resource name, FHIR patient, and then an ID that uniquely identifies that record. So we're mapping our data onto web URLs. So this might be where a good time to do a little demo for you. If I go to this website here, so I think there's a link to this in a couple of slides. I'm slightly getting ahead of myself, but this is it's a website like any other, and you can go there now if you want to copy it and have a play. It's a real live website, but it's also a web front end, a proper FHIR front end on a web server. So it's a kind of combination web page and FHIR server. And if I was to hover on this link where it says JSON here, at the bottom of the screen, if you can see it, you might see a URL building up. It might be a bit small to see, but if I click on that, it'll take me to a page of data. So I've got a web address here, like we saw on the previous slide, with a patient URL, and then an ID, a play number, just one, and a command to say, give me JSON rather than XML, for instance. And I go to that, what looks like an ordinary web address, and I see healthcare data. So I've got a web server serving up pages of raw data. So that is kind of REST in a nutshell. It's web pages that are not HTML but are data. Now this would be secure. I'd have to log in, I'd have to be connected, all the tokens, etc. But obviously, once you've done all that in a real system, not your human, but your software that reads HTTP, your software that reads web pages, would go to this address looking for patient 1, which it must know by some other means, which we'll come to, and you get a page of data. Or an XML, let's pick a different number, let's pick number 5, and I didn't put the JSON suffix on, and this server happens to default to XML, so I get some other data in XML. So we've got pages of FHIR data mapped onto web pages. Yeah. And if you look down the bottom here, you can see a link to the general practitioner. Hopefully that's visible and not too small. You'll see organization 1. Organization is the name of another FHIR resource type. And this organization 1 is saying there's a link from this patient to the general practitioner, which is organization 1. If I was to take that little fragment there, I'm just copying that, and put it onto my server address here, and go to there, you see another page, organization 1. So you can start to see a pattern of a series of web pages, a bit like records in a database, but kind of, it's like a database crossed with an intranet. So we're mapping our data onto, a web sort of analogy, and then, organization 2 and so on. So links between hyperlinked data. Let's move that aside and get back to our main thing. Yeah, so we're seeing a resource lives on a web page. Yeah, and if I was to go to this made up server with this official FHIR keyword and this number, which is a particular number for that implementation, that particular patient has been assigned this internal random number. It's not their NHS number, it's their sort of record number in FHIR. If I was to go there, I'd get hit by a page of data. Let's move along because we're running a little bit behind. You can do similar URL-based searching. So if you don't know that internal number, you can suffix, question mark name equals Smith, and find that sort of thing. So you can you don't need to go directly to a page, but you can come up with a page of hits about FHIR data, look things up. That's where I was going to do my demo, but we've just done that. There's a shortcut to that server on that link if you want to go and have a look around that. Right, let's talk about what you might sort of do with FHIR when you come to implement FHIR for the rest of our slides, and I'll talk a bit about profiles. You may have heard of FHIR profiles. They're a lot of people are building FHIR profiles. I'll tell you what they are and kind of tell you why you need them or why you might not need them. FHIR is a flexible international standard. It has kind of everything in it, but it doesn't tell you how to use FHIR in your hospital or your dentist or your GP in the UK. It doesn't know about UK specific contexts. So we need to localize FHIR, for England, Scotland, Wales, for France, surgery in Canada, general practice in Australia. All of them have their own unique ways of working, terminology, types of identifiers. So we might want in the UK to mandate not any old identifier, but the NHS number or the CHI number for Scotland. So we use profiles for writing down those sort of context-specific extra business rules. That's what profiles are for. So when you do profiling, you create profiles and you put them in an HTML-based publication, typically, and that's called an implementation guide. So an implementation guide of FHIR is typically a set of FHIR profiles. And yes, it says do this with FHIR, don't do that with FHIR. In the UK, we use SNOMED. We don't use this other sort of thing. Do use this resource, don't use that resource. So we're sort of boiling FHIR down to a more local specific thing. And you could do it for your particular use case. Maybe you've got a referral system or whatever you have, you will only need certain resources for that referral system, and you pick those ones, decide which bits of them to use, and you either just get on and implement it, or if you want to be sort of more document oriented, you could create a profile that tells all your stakeholders how you're going to implement it. So you don't have to write the profiles, but they're a good way of capturing your requirements. You need to have your requirements. Whether you capture them in profiles or not is kind of up to you. So what people tend to ask about profiles, do you need profiles? I have to get profiles to use FHIR. Yes, surely, because everybody's doing profiles. No, profiles help, but FHIR is there anyway. You can start using it right now. But there are profiles that people are writing for you, like UK core profiles. Somebody out there might have your use case and have already written some profiles. So they're a good sort of set of rules for using FHIR that might be useful to you. If they know about your context or you share the same use cases, they might be good for you. But even without profiles, or even with profiles, you're still going to have to make some choices about which bits of FHIR you implement. Nobody implements FHIR, you implement, certain bits of FHIR in certain ways. It's a toolkit for doing interoperability, not a single off the shelf. You just do it. So they're not mandatory. They don't change FHIR. They're like a selection of FHIR. They're like a little editing process where you say, we're going to use this and that, which bits of FHIR we're going to use. And profiles have this other advantage that they are machine readable. So you can say, oh, I'm going to validate that you really are using the NHS number. You said you were going to, but I want to make sure that your JSON really does have the NHS number and not some other, GP number or whatever it might be. So in effect, you take the patient resource, which we've seen already, and you kind of restrict it down to make a sort of mini patient resource. In effect, you're sort of remodeling FHIR. You're limiting things. You're changing the cardinalities. You're changing 0 ... star to, for instance, 1 ... making it mandatory, but only one of them. And you can constrain out bits you don't need. You can add your own code systems in there, where in the general standard it's a bit open. You can get more specific, and you can add extensions. We mentioned extensions. This is the point where you introduce extensions and document them in your profile. So it's a subsetting process, and then you produce a new document, and it says, this is the UK core, a little screenshot. It says, in the UK, or certainly in England at least, we're going to use this particular flavor of FHIR identifier, which is called NHS number. And we've introduced some extensions as well, which are pertinent to the UK, such as the UK set of ethnic codes, which are different to the ones perhaps used in some other countries. And these have been decided by some NHS body probably. So the UK core set of profiles, a link at the top there, just add some extra little UK flavorness to it. We don't take away the name of FHIR. We don't add too many new things, but we add a little sprinkling of, probably NHS-centric things, to be quite honest. So FHIR profiling, it's a document of how to use FHIR in a given context. And people are doing them. You don't need them, but they're a good way to sort of share your specific FHIR requirements. Okay, so say you've got FHIR, you want to get going with it. How do you actually, what stuff is there for you to use? You want to actually, cut some code. So FHIR, this slide really says that FHIR has a lot of stuff. It's got a lot of open source. It's got platforms. It's got events. It's a community, is what I'm trying to say. But say you're, just trying to read some data. That FHIR exposes some data. We saw a little demo server with some data on a web page. How would I get to grips with that? There are test servers, of which my demo one is listed. Go to this Confluence place, and you can see open source databases online with FHIR data, which you can browse around with browsers, or you can use Postman if you're familiar with that sort of tool. You can search for patients called Smith. You can search for observations on a certain date, and just kick the tires and do a bit of reading and writing of FHIR data just to get familiar with it and the headers you have to send, and how do I get JSON, how do I get XML. You can play. It's and they conform to the standard. So when you read some data, one way you write your own code to do it. If that works against the public test server, you've probably got it right. So they're good for testing against. But once you get beyond the kind of Postman doing it by hand sort of thing, you want to be writing some code probably if you want to develop with FHIR. And these languages are supported in open source code toolkits for FHIR. A link there, I won't go there, but it will take you to downloads that let you do things like this. So I'm not going to take you through this C# code, but there's code for these classes. There's a FHIR class built called patient, mimics the patient resource, a FHIR client resource where you can give it the name of a server, and tell it to read a patient with a certain ID. It builds you an object with all the right properties. So you can set the name to these things and then update the server. So you can see a little RESTful interaction going on there, but all with library code. So it knows how to talk to a FHIR server. It knows what the patient object is like, and that's all built for you in a C# library if you choose to use it.
Rick, just point out it's 1745.
No worries. So some links to that C# library. And I won't go there, but there's C# stuff for you to use. If you're more of a Java person, a similar example, reading from some server, and this example, which to look at later perhaps, issues a search for people with the name of duck, and then prints the results of it. So 2 or 3 lines of code with obviously a lot behind the scenes, open source code that gets Donald Duck, Daffy Duck, and etc. There's your Java Happy links. It's a Canadian project, so it has a little raccoon. So what are these FHIR servers? There's open source ones there, but if you want to expose data, you would be a FHIR server from your own. Maybe you've got a GP system or a EHR, or any little patient-centric system, and you want to expose some data. That means you're acting as a FHIR server. So you need to add on an HTTP RESTful layer probably, and start reading and writing FHIR data. That's a bit of a heavy lift. In fact, I mean, REST is kind of the easiest way of exchanging data, but it's not trivial. There's code for that as well. Open source, free code for that. So the rest of the world can speak to some off-the-shelf open source code that you build onto your Brown existing system as an extra sort of layer. It instantiates objects like the Java ones we've just seen that represent the request that comes in. I want patients called Smith, or whatever it might be, or here's a patient with this data. It turns that into objects that you can then write the code to map that to your internals. So nobody's going to do that mapping to your own data model for you, because it's your data model. But there's all sort of interceptors and APIs that you can use to make that connection. So you deal with your bit, but when it comes to parsing up JSON and FHIR and responding to HTTP requests, it can all be done for you. Other parts of the FHIR ecosystem, we've got test data. So this is a test data generator called Cynthia, synthetic mass. And it has 1 million patient records that represent people in Massachusetts. And, that might be different to people in this country, but, broadly similar with realistic data. So realistic people, old people have heart disease, babies have jaundice and not the other way around. So realistic data for testing, and you can generate your own data with various profiles and age groups. And do I want all women for a gynecology system, all babies for this, that, and the other? All sorts of tools are appearing around this ecosystem. Last few slides, a couple of visualizers. So ClinFHIR tool is a great sort of clinician flavored, focused thing for sort of typing some data in, turning it into a resource and visualizing it. It's worth a look if you're sort of more, clinical focused. Link there for you for looking at later. A shameless plug of something that I wrote, this thing called Viewer. You can point this website at a different FHIR server, and it will, rather than giving you a bunch of JSON like you just saw, it will give you something that looks a bit more like, a bit more HTML based. So you can see, okay, I can see where the date of birth goes, and I can see where this bit and that goes. So a little server explorer you might want to try. Where to go for assistance as we wrap up. So chat.phir.org if you really want the kind of fire hose of FHIR data, bug reports and feature requests, Confluence, and we support Stack Overflow. That's a lot of people go there. So some links for you. Chat.phir.org is really the mother lode of FHIR. Last one from me. Read the spec. Go to chat.phir.org, as we've mentioned. We're on Twitter. Various events linked to a sort of excellent once a year international meetup. Plug for FHIR training down there if you want to get some like this, but more. If you want 2 days of this, if you really want that, get in. We haven't got the next training date yet because it's the summer, but we'll be doing one in the autumn. So get on and let us know you want training. That's overrun, so apologies, Mike. Not too much time for questions, but hopefully that was useful.
Oh, thanks very much indeed, Rick. That was absolutely superb, absolutely fascinating. And I think the audience has been very privileged to be able to hear that. And there may not have been as much time for questions, but my goodness, you've imparted an awful lot of information, and importantly, given a huge number of places where people can go and find out more. So that's absolutely brilliant. Charlie's been looking at the chat while you've been talking, so okay. I think we've got time for a couple of quick questions. We obviously can't go through them all, but Charlie, do you want to just highlight any particular ones that you thought were of particular interest?
Yeah, there are a couple of a few interesting questions. One around SNOMED, or a couple around SNOMED.
Yeah.
One challenging your statement that it's the most complex of the ecosystem, and another asking
On that
about,
slide.
on that slide. And then the other was asking whether SNOMED's complementary to FHIR or competitive.
Very much so. Yeah, very much so. Yeah.
And how do they work together? Because there is a difference in the concept models.
Absolutely. Yeah. I mean, yeah, they're designed to go together, and there's a little bit of wiggle room in that. But essentially, FHIR is kind of an information model. It's a bunch of structures for plugging data items in. So you plug your dates in, you plug your strings in, and you plug your codes in. And that code could be SNOMED quite easily. So yeah, FHIR is almost like a tree for exchanging dates and times and codes in a way. And it has some of its own codes, but when it comes to clinical codes, it's very much waiting for you to plug your SNOMED codes in there. Yeah.
And do we think that the sort of this vision of a dynamically assembled healthcare record will become prevalent, or do we think that EMR manufacturers are resisting that, and they want to keep their walled garden with small FHIR gates that allow occasional use? So
yeah, obviously a bit of both. I mean, there's yeah, I think the sort of EHR world is becoming a little bit more monolithic, perhaps, and the US majors are on our doorstep, but most of those are relatively open. They have FHIR APIs. You might find the entire hospital runs on one clinical system, but they do have FHIR APIs that let you plug in your third-party radiology or whatever. So a bit of both, clearly. Yeah.
Around the sort of localization, so the differences in either within countries or between countries, so between Canada and the UK is the example in the question. Given that 80-20 rule, do you see that localization as leading to a barrier to the establishment of a global standard that allows plug and play and people to sell products across countries?
I don't really see that. I mean, people want one healthcare standard that will just do everything in the world, but that's basically not really possible, because different applications do different things anyway. Your dentist cannot exchange data with your anaesthetist, because it's just slightly different data. Even if we do it in one perfect format, people have different use cases and different, so there can't be one thing. So there will be differences between data in Canada and the UK, and it's never going to be completely plug and play, because that's just the world of healthcare. So yes, there are differences in FHIR profiles across the world, but I think they're minor compared to the problems of just aligning different things anyway. It's not so much a data standard problem, it's the fact that healthcare and data are different in different domains anyway.
Yeah, and just by getting people to be using the same FHIR framework, that takes them a lot closer than if they're using different frameworks.
Yeah, the last mile, you might have to do the last mile. Nobody said it was going to do the whole thing for you.
Yeah, that's. Another question was whether there's any sort of automated production of Swagger documentation for FHIR profiles or FHIR specifications.
Yeah, interesting question. People often ask this, and people have done that, but the fact is that Swagger is not quite flexible enough for some of the clever things that FHIR does. So people do FHIR, people do generate Swagger. I haven't got any links right now, but it's a commonly asked thing on chat.phir.org, and you'll find some links for people who've got Swagger generators, and you'll also find some people that say FHIR has better things than that already. So yeah, you might want to go even beyond Swagger type capabilities.
So I guess the advice then to anyone who's wanting a Swagger specification would be to have a look at the chat, the HL7 chat link, and look at some of those discussions.
If you search on a very specific word like Swagger, you'll find threads about Swagger.
And that's worth exploring, because it's best not to assume that that's going to be a fix-all for everything. That's grand. And then there are a few questions about access to the slides and the recording, and those will be posted on the booking page. So the fact you managed to get to this presentation means that if you go back there in a week or so, those materials we posted up there.
I should just say the recordings are taking a bit longer to come through from the BCS, but the slides will definitely be there early next week.
Right, and I think that covers most of the questions that I've seen in the chat.
There's one about what the little symbols on the resources mean.
Oh, yeah.
So if you look at patient resource, here it is. You can see, well, yeah, so here's FHIR. Go to FHIR, click on patient. If you can find it, you get a nice web page, and you can see a sort of tree view here. And you can see this, the UML diagram I showed on the slide is on this other little tab. Yeah, but you start to see some sort of cryptic things like this, don't you? And that means it's in the sort of summary subset, and a few other things. That means it's got that means it's a sort of important modifier element. But the answer is to click on this. I think you click on flags. I might be wrong. And it tells, yeah, that right. It gives you a kind of, it tells you what these things are. So if you can't remember, and I often can't remember what they all mean, the answer is to click on the flags thing, and it tells you what they all are.
Excellent. Well, and beyond that, there's been a lot of appreciative comments thanking you for your presentation.
It's very nice. Apologies to the SNOMED people I offended.
So, well, I
that's
think
a great thing. It just can be complicated.
I think I would disagree with you on that one, Rick, and say I would say that using SNOMED, it's really worth using a terminology server, and there's a FHIR interface to terminology servers.
Yes, indeed.
And if you're doing that, then a lot of the complexity of SNOMED is hidden.
That is absolutely true.
Get on, do
absolutely, that is absolutely true. And there's some great new ones. The NHS has bought one recently, and it's I know from personal experience that it's extremely good and very useful. And
that ability to manage value sets in a central, in that NHS terminology server, I think if people adopt that more widely across the country, I think that'll be really helpful, and it'll allow for consistency and effective reuse of terminology, not just of the information model. So I'd put a bit of a plug for that, and also say that although there is some complexity in SNOMED, there's complexity in having thousands of different value sets in different code systems. So it's part of the inherent complexity of the space.
It definitely is. SNOMED reflects the real world, basically.
Okay, I think it's probably time to wrap up at this point. So just before I do that, this is, as I mentioned right at the beginning, the 4th webinar that we've had in the series. The next one will be on Thursday, the 20th of July, and that will be about the standards that you use to ensure that systems are safe. So please join us for that. The joining details will be sent out as soon as possible. And please be on the lookout for unusual routes because of the problem with Twitter recently. We're not able to communicate quite as well as we used to be able to with our prospective audience. So the last thing for me to do is just to reiterate my thanks to Rick for an absolutely superb session. You really don't have any excuse for not being able to go away and look around and find things about FHIR and get answers about FHIR after that. I mean, it really should inspire everybody to get going with FHIR. So many thanks again, Rick, and see you all next time. And I'd be very grateful if those of you who are still on the call could log off so that we can just have a quick debrief amongst the speakers. Thank you.
Thanks all. Thanks for listening.